slides for you here as we get into the content. So Rad Studio 12 Athens. Really excited about this release. Big things to call out that this includes. This is an update to C++ Builder. So C++ Builder 12 Athens, now with Visual Assist for C++ Builder, and then Delphi 12 Athens. You'll see our new splash screens here, and these will be in product for you. And then as we go into our agenda, today we are jam-packed, so I'm trying to breeze through this quickly for you. As you can see on the screen, we've got a lot to share. There's been a lot of work behind the scenes in this release from many partners, many architects, many developers, and so we're really excited about it, so we want to share that with you, obviously. Throughout this, there will be a combination of live sessions and recorded pieces of this, which allows you to stay engaged and ask any questions that you might have throughout the broadcast. And the team that you just met will be behind the scenes answering those questions. So you're more than welcome to hold those into the QA at the end. But throughout the webinar broadcast, we really encourage you to ask those questions as they come up, so you don't forget about them. We'll start off with C++ and the focus there and what we've done with the IDE and C++ Builder. Then we'll move through a few of the different pieces of our tool chain into Delphi updates, FireMonkey, Skia update, VCL. And so there's a lot here, as you can see. So we'll try to go ahead and move through this quickly. But we really appreciate you being here with us today. And again, just a reminder, ask questions. We will have follow-ups throughout, follow-up webinars as well on specific pieces of this. But don't be shy, and thanks for joining us.
Yeah, and I want to start with what I think is one of the most amazing things we've ever done for Rad Studio, and that's the inclusion of Visual Assist for C++. Visual Assist is a sister product within Idera, and is a productivity plugin for C++ and C# developers using Visual Studio. Pretty much any software you use has been written with its help. I can't name names, but I can say that you've likely used multiple items of software already today, or even possibly to watch this right now, that Visual Assist helped create. It really helps productivity, and it's been a key part of Windows C++ development for years, and now it's joined C++ Builder. We had a preview webinar in August, but we showed you only a few things in that webinar. What we're delivering in Rad Studio 12 goes past what we showed in our preview. We are shipping more features than we previewed. I'm going to start off with some good features, and there's a whole host of great things, and move on to showing you something that I think is about the most amazing feature ever. Let's begin with code completion. In C++ Builder 12, we still support LSP and CQuery, but by default, all Code Insight features are provided by Visual Assist, and that includes tooltips and parameter completion, which we haven't even got time to cover here, and just for the sake of time, that single sentence is it for describing those features. But when using Visual Assist for Code Insight, you are using a new Code Insight engine. Focusing on the code completion part of Code Insight, it's important to note that this is very different to our previous code completion. Don't expect the same thing. Previous code completion was essentially based on a compiler, and so often required code to be in good compilable shape, and its results were always from the compiler, and therefore completely 100% correct. Visual Assist, though, has a fuzzy parser, and it can happily handle code that won't compile. It'll do everything it can to understand the code no matter what. And although Visual Assist obviously parses and understands your code and presents completion based on the type of your symbols as you'd expect, as well as a flexible fuzzy parser, it is also heuristic in results. As well as completely standard suggestions, it will suggest things that may or may not be what you're looking for, so you will get different behavior than with CQuery or even classic completion. It is also very fast, incredibly fast. Even better, it can suggest things that technically it doesn't even know about. In the screenshot on the left, you can see it's suggesting the standard library map classes. But the code that it's suggesting inside, the code where the text cursor is placed and you're completing in, doesn't have the headers for stdmap or multimap or unordered map included. So, how does Visual Assist know how to suggest them? Well, other than magic, it can do this because it's not aware just of the current file and what the current file uses or includes, the way previous code completion was, but because it's aware of the entire set of headers available to your project. And so it can suggest things you might want to use, whether those are standard library types or even types in your own project you just haven't added the include for yet. A natural question might be, can Visual Assist both suggest something in code completion and also add the include for you? And I'll get back to that in a minute. But that's code completion as provided by Visual Assist, which is the default now in 12.0. Definitely different. It's the same feature, but not an exact replacement, and you'll likely have the best success with it regarding it as something new. It's fast, amazingly fast. It's fuzzy, it produces results even when code doesn't compile, and is heuristic, and it can even suggest things that aren't even in your code yet. Let's move on to refactorings. In the webinar preview in August, we previewed one refactoring. Well, we're shipping 4, 2 major ones and 2 minor ones. And these address common things you need to do in your code. Refactoring is all about code maintenance. As you develop, you need to change code and you need to move it around, keep it up to date, change things. That's what refactorings are there to help you do. And the key things we've added in version 12 help you rename a method or type anywhere it's used in your project group. This is what we previewed in the August webinar. But there are other things you might want to do, such as automatically add the right include for the code you've written. Or, taking some inspiration from a Delphi feature, you might want to write a method and have the declaration automatically added, or vice versa, write a method declaration and get the implementation automatically added. And that's what we have, so let's have a look at these live. First, let's look at rename refactoring. Renaming something is a very useful operation, so we'll use this test app, which is a small but non-trivial real-world app which we publish on our GitHub, to demonstrate. You can rename anything, but here I'm going to rename the grid type because it's a key type used throughout the program. You can see when I open the dialog, it lists all the references it finds to grid, and there are checkboxes to control where it looks. Note that you can rename across an entire project group, not just one project, which is key. And also note that Visual Assist can find references in comments and strings. Refactoring is about code maintenance, and it's not good maintenance if your comments get out of date. So we can scroll through this and give a quick visual check what it will rename, looks good, and also ensure that we check the checkbox next to the comment it found so it will rename there. And when we click rename, it renames through the entire project and project group. Note when I go find that comment that is renamed there too, which is unusual for any refactoring tool, but not for Visual Assist, because Visual Assist does things that are meant to be useful and go beyond what other tools provide. And of course, if I recompile, you can see the app still builds, a fundamental test and a very good one. Let's move on to the next refactoring, add include. In the slide earlier, we mentioned code completion and that it could complete for types that aren't even in the current unit yet. To demonstrate this, let's add a completely blank unit, and you can see that other than its own header, it has no other includes, and it does not know about key types. It does not know about C++ strings or vectors or maps, and does not know about even the types defined elsewhere in this program, because we haven't included them. So let's write some code, and we'll add 2 types, a system include like map, and one of our own apps types. We have code here that needs some include files added. Visual Assist works very tightly integrated to the symbol that your text cursor is in, which is worth remembering if you want to invoke functionality, that you need to put your cursor in the token that you want to do something with. For us, that's map. Let me put my text caret there, and then in the refactor main menu you can see add include, and it tells us which header it's going to add, map. When I click that, it's added. Let me do the same now for grid. This time I'll use the editor context menu, and you can see again it tells us that for the grid type it's going to add a specific header. Now I have the to includes added at the top of my unit. Let's do this for a more complex case. Rather than a new blank unit, I'll go to some existing code. Now this unit is UE agnostic. It has no UE code at all. It doesn't know anything about drawing or buttons or anything, and we could include it into a VCL app or a command line app if we wanted. And I'll add a bit of code referring to a UE control, a T button. When I right-click and add include, you can see we'll add the include for fmx.stdcontrols.hpp. Now, there's a T button type in both FireMonkey and VCL. How does it know to use a FireMonkey header when we're adding an include in a file that has no FireMonkey present? The answer is that Visual Assist is aware of the framework you're using for your app, and is able to know that you need the FireMonkey or VCL versions of a header. And this is the same for any other situation when it needs to resolve and find information about a type. And we've seen two things today. We've seen code completing types that the current code isn't even aware of, including with both types in our own project group, and the STL or any other headers that count as system headers, like the ones in Getit. And we've seen including the right include file for any type, just by right-clicking it and selecting Add Include. Now let's move on to the two smaller code generation or refactoring operations, which also live in the refactor main menu and the editor context menu's refactor submenu. Let me add a method to the grid class. Now, normally I now need to go into the grid.cpp file and add the implementation, which is fine, but it's the kind of work that I should be able to automate. If I now right-click my new method, and remember that I have to click the name itself like everything else with Visual Assist, and select Rename, Create Implementation, you can see Visual Assist goes ahead and creates a skeleton implementation for me. You can do the same in reverse, and use Create Declaration if you create a method and want the declaration added. So those are the refactorings we've added to our initial Visual Assist integration. We have two large or major refactoring tools to rename any symbol and to add the include file for any type, and two smaller ones where you can automatically add a declaration or implementation. For the final set of features out of Code Insight, refactoring and navigations, let's look at navigations. Navigation is another key strength of Visual Assist, and we have some really useful features here. Rather than have a lot of slides, I'm just going to jump straight into a demo, starting off with the small ones and finishing with my absolute favourite feature in Visual Assist. First, the smallest feature, but actually a feature that is one of the most highly voted requests we have for C++ Builder. A few minutes ago, we looked at automatically creating the implementation or declaration for a method, but it's also really useful to quickly jump between the implementation and declaration. This is a fast way to get between methods, and also just a fast way to get to the class header or a useful part of your code. In Delphi, you can do this via Control-Shift up or down arrow, and we've added this to C++ Builder now too. As you can see, I am toggling between the method we just added in the header and the CPP file entirely via the keyboard. Just as an aside, I've stressed that for Visual Assist you always need the editor cursor to be in the relevant symbol, not just nearby. This feature is an exception to the rule, and will work when the cursor is in empty space in the method too. It doesn't have to be in the method name. There are also menu items for this, because we think key functionality should be available in menus, not just hidden behind shortcuts, and you can find this in the search menu as Go to Definition and Go to Implementation. These menus are present for Delphi as well now too, which is why they don't have the Visual Assist tomato icon, even though for C++ they're implemented with Visual Assist. The menus let you specifically go to whichever one you want, but the Control-Shift up or down shortcut simply toggles. Let's move on to a major code understanding and navigation tool, Find References. Find References is a tool that lets you find where something in your code, like a class or method or anything, is used or referred to. In fact, Rename Refactoring uses this under the hood, because in order to rename everything, Rename has to know all the references to whatever it's renaming. And it's very useful for you, because Find References lets you find any code that uses the code you're looking at now. Let's try it. What parts of this app use the binary tree method? Right-click Find and find references. Okay, that's not very many. Let's try something larger. What about the cell type? I can go to Search Find References and it will show me. You can see this type is used extensively throughout the app, and not only does it tell me every reference, but it tries to give a bit of information about the class or method where it's used on the left too, such as this one, where you can see the reference to cell is in the Aldous-Broder method. Of course, I can double-click or press enter and go there. Find References is not just a code understanding tool, but a navigation tool too. We also have a menu item to find references in Unit. Find References by default looks in your project, and you can click a toolbar button to look in your entire project group. Find References in Unit is similar and just looks in the current unit, which is useful when you're trying to do what is effectively a local search and know you want something in your current code and there's no need to look through the entire app. Note that Find References is not a search. It's based on parsing your code and is a database query. In other words, it's not a text search. And that means that the references it returns are the actual real references in code. The next feature, and wow, there are a lot of features we're shipping, is Find Symbol. This lets you find any symbol that Visual Assist knows about, and this is not just symbols in your code directly, but all the headers your code uses and all the headers they use and so on. Let's invoke it. You can see in the title bar that it knows about 160,000 symbols, and you can search for any of them. I'll type get window, and you can see it updating live. That's very fast response. It's searching constantly as I type through over 160,000 symbols here. You can see it found many results, but selected the most likely, which is the Windows API method getWindow. And this is what I mean about Find Symbol finding anything and knows about the Windows headers, for example, among all the other headers available to it. If I search for something else like grid, you can see it shows the grid header, the macro in the header that's in my project, and a few lines below the grid class. Here I want to demonstrate some of the other search features. I can click a checkbox to search only for symbols in the project group rather than searching everything Visual Assist knows about, and you can see the results changed immediately to a much narrower set. I can also search for only classes, structs, and namespaces, and immediately it shows just the one matching result, the class grid. These are very powerful because Find Symbol will find anything, and these options help you filter down results. There are also search filters, so I can search for words that begin or start with a certain term. If I type MN, it gives me results containing column and columns. If I put a period at the end, MN dot, it means that I want results that end with MN, and you can see that only matches two symbols. I can also put a dot at the beginning to find only symbols that start with the search term. So just as a quick recap, Find References is to start with a symbol in your code and find references to where it's used, whereas Find Symbol is to find any symbol that exists anywhere. Next, let's have a quick look at GoToMember. This is a small but useful navigation which lists, and lets you navigate to, of course, all the member fields and properties and methods of a type. So, if I put my cursor in the symbol, I'll use grid again, you can see that it lists every method and field in the grid type. But it's a bit smarter than that. If I put my cursor in this expression, image viewer arrow bitmap with my cursor inside bitmap and go search GoToMember, it knows this part of the expression refers to a t-bitmap, and it shows me the members there. In fact, I can even put my cursor in the assign method call, and it knows it's a call on the t-bitmap type. And so when I click GoToMember, it will show me the members of t-bitmap. And of course, you can search and filter and go to any of the members. Now, I've saved the best for last. There is one more menu that we have not looked at yet today, and it's my favourite. And that is this menu item, Go to Related. This is, in my personal opinion, the most amazing feature ever, and I have used it any number of times since we first got it integrated. GoToRelated's job is to see what you clicked on and let you navigate to anything useful related to it. It is so useful, we've integrated this more closely than the normal main menu or editor context menu. RadStudio has a feature where you can hold Control, and as you move your mouse, symbols turn into hyperlinks, and you can click them to go to their definition. And in C++ Builder 11.3 and before, we had that. In C++ Builder 12, control clicking on any symbol instead invokes GoToRelated, because one of the related things is going to a definition that's still there, but you can go to a whole lot more. So while I can use the search or context menu GoToRelated, for this demo I'm going to hold the Control key down and click on things. Let's start small, something basic, a namespace. This app has a namespace maze which is used in multiple areas, and you can see it used here in this method. If I control click on it to invoke GoToRelated, I get a menu popping up, and this lists all of the definitions of the maze namespace. If I expand the menu, you can see everywhere that I have defined the namespace. And of course, click one to go there. Now this might give you a hint where this feature is going. Let me now click on a member variable named mpgrid. The menu pops up and I can go to the declaration. Great, that's where it's defined. But I can also go to the types of the variable through this types of symbol menu. And this variable is a unique pointer of grid. And you'll see Visual Assist knows that, and both are listed here and I can navigate to either. This means that you can find and navigate to the various types that make up a type, in that Visual Assist will allow you to separate the template specializations and navigate to each one. Even better, I can also invoke the GoToMember dialog for both this variable and even for the form that it's a member field of. You can start to see what we mean here by GoToRelated. It picks up anything useful and lets you go there. But we are just getting started. One of the key things about object-oriented architecture, like C++, is polymorphic inheritance. So let's find a class that inherits from other classes, and in turn, has other classes inheriting from it. A good example is tCustomButton in the FireMonkey framework. Of course, this works for any class at all, VCL classes, your classes, anything. If I control-click the typed name, tCustomButton, we can go to the definition and go to a member. We can also go to the constructor, which is useful. But what's really neat is that you can find the ancestor classes for this type. Here, when I mouse over base classes, it shows all the ancestors. I can click to go to any of them. What's equally useful is that I can see the derived classes when I mouse over the derived classes submenu. Note the caret symbols that show how deeply nested the inheritance is. This lets you at a glance see what classes inherit from a type anywhere in your project group and go there. This works clicking any type, so even though I'm now at the tSpeedButton declaration, I have the type name tCustomButton on screen and I can control-click that to see the same menu. Or I can control-click any other type. What about tBasicAction here? You can see how it has 3 ancestors, but has quite a few derived types, and note again that you can see how derived they are by how indented they are. This is incredibly useful. It lets you navigate through the entire inheritance tree of your software, starting from any point in that tree up and down. But it doesn't stop there. What about virtual methods? Let's try tBasicAction and I'll go to its constructor. Again, control-click to invoke GoToRelated. There's a virtual update method, and if I control-click that, you can see that this time, because I clicked a method, instead of a derived type submenu, I have a derived symbol submenu. And expanding it, the update method is overridden by 6 descendant methods, and of course I can now go to any of them. This too is incredibly useful because a big part of object-oriented programming is dealing with or understanding what method is actually called, what overrides there are, what method implementations exist, and moving between all the related classes and methods. Now, Visual Assist is not just a simple integration into C++ Builder. It knows about C++ Builder-isms, like properties, and we haven't touched on that yet, but now's a good time. We just looked at virtual methods and seeing the ancestor method implementations and derived overrides. There's a method here that is dynamic, and that is an entirely custom kind of method that is effectively virtual but internally different in how it's called. But to be useful in C++ Builder, we had to teach Visual Assist that dynamic methods exist and what they are. And sure enough, if I control-click this dynamic method execute, you can see it lists the derived overrides of the method correctly. Let's look at properties too. If I control-click one of the properties, you can see that Visual Assist shows where the property has been redeclared in the descendant types. And of course, you can go to member, and the listing of members includes the properties, as well as the backing field and setter method. GoToRelated works on pretty much anything. You can even try it on header files. You can see what other files a header includes, and then even see what files the header is included by. And there's more. We're out of time, but when you install Rad Studio 12, just go around control-clicking on stuff and see what you get. So that's Visual Assist in C++ Builder and Rad Studio 12, an amazing initial integration. You have code completion. It's different to the past. Don't expect the same. It's new, different, it's fast, and heuristic. You have multiple refactorings. Rename any symbol, add the right include file for any type, and create method implementations and declarations. And then you have a whole heap of navigations, tools to help you understand the structure of your code and move swiftly around it. Find references, find symbol, toggling between the implementation and declaration, go to member, and GoToRelated, which takes you to anything useful related to whatever you click on, to the declaration and constructor and base and derived types and base and derived virtuals, and I think is the most amazing feature ever. And it's all got C++ Builder extras. It understands code that uses things like properties. This is huge for your daily productivity, for moving around and understanding code. It's fast, speedy, contextual, and I think is one of the best things we've ever added to the product. I can't wait for you to try it, and don't forget that CBuilder and Rad Studio 12 are out right now. Let's move over to the other big news for C++ in Rad Studio 12. We've discussed before, both in a blog and a webinar, that we're upgrading our C++ compiler, and in fact, not just the compiler, but the entire toolchain. For the sake of time, I won't go into too much detail, but we're aiming at excellent tools such as a new linker, at using platform standards like the PDB debug format and the COF object file format, at multi-standard library and more, such as allowing new code optimizations that were not previously possible. We're using a lot of LLVM and related tools, and the toolchain is looking really exciting. It uses the Universal C runtime for the C-level RTL, which is a standard Windows component. It uses a custom C++ runtime, and it uses LLVM's libc++ for the STL, which has great standards conformance. Redoing things like the custom C++ level runtime really emphasizes our approach of doing it right, where things like, for example, exception handling and SEH are fully reworked for excellent compatibility and correct behavior. We're even replacing the linker, which will be exciting for those of you with very large projects, and of course, all this is keeping everything that makes C++ Builder C++ Builder, such as supporting Delphi using things like properties and of course much more. This is available as a preview in Rad Studio 12. One of the big themes with this toolchain is doing it right, and that means taking our time, thus shipping a preview, not the final release. However, the preview is very exciting, and we expect many of you will want to test it out. For the build in the 12.0 release, the compiler is focused on pure C++. In other words, you can't yet create a VCL or FMX application in the build that we have today, although Delphi extensions like property are working. You can, however, test out the C++ tech that we're using, build using the command line, but you can debug within the IDE itself. Let me show you using some code I used for a webinar earlier this year, which measured the performance of C++ maps. This code was written with Visual C++, but I'm using it unaltered with the new Win64 toolchain, as you'd expect. For the sake of pointing it out, if I'd written it with C++ Builder, it should also work unaltered, as you'd expect. We're aiming at excellent compatibility, of course, with the previous C++ Builder, which goes unsaid, but also with other toolchains and general C++ code. I can build it on the command line. Here I'm building statically and emitting PDB debug info, mainly just for the sake of the demo. Note that the compiler is invoking the LD LVM linker. We aren't using ilink anymore. In the IDE, I can go to the Run menu and then use either Attach to Process if it's already running, or Load Process, and select the modern Win64 LDB debugger for C++. Make sure you choose that, not the other C++ debugger. If I place a breakpoint, you can see it pausing. What's notable is that you'll see its CRT in the messages view, and you would see it loading the libc++ STL if I'd built dynamically, and it's loading PDB debug info. So that's the technical preview of the upgraded Clang toolchain. Command line building, but IDE debugging at this stage. It's completely reworked, using platform standards, capable and performant STL and more. There's a large amount of work that's gone on under the hood to get us to this stage, and we think you'll find testing it out very exciting, especially if you've ever wanted to move away from ilink, use specific STL templates, or anything else where this new toolchain has a very strong emphasis on quality and being the absolute best it can be. And it is the best. We are approaching this with a strong focus on doing it right, and we're definitely looking forward to your feedback now and as we continue with it.